Welcome to Ask and Learn.
So they want us to draw the Hasse diagram for divisibility on these four sets here. So actually, let me go ahead and just move these out of sight for a second, and then we could just do this on A. All right, so we start with this. So we're asking ourselves, can these numbers divide any other number in the set? So let's start with the largest and work our way down, because I think it would be easier to do that. So let's see. So we have 8 here. So 8 can't divide anything other than itself. So we have that. So actually, one thing I'm going to ignore in this, so remember the Hasse diagrams, we don't have the reflexive loop. So we don't need to draw that in this. So if you want to just draw the directed graph, you can first and then kind of remove everything. But just so it's not too messy, I'm just going to ignore the self loops on this. All right, so 8 doesn't divide anything, so it's just by itself. 7 doesn't divide anything in here. 6 doesn't, 5 doesn't, 4 divides 8. So we can come over here and put this underneath 8. 3 only divides 6. And then 2 will divide 4. It divides 8, and it divides 3. And it divides 6. Okay. And then we have 1, which divides everything. So we have 1 goes to 2, goes to 4, goes to 8, goes to 3, goes to 7, goes to 6, and goes to 5. Yeah, so we have this. So it's kind of messy right now. Now, one of the things we know about Hasse diagrams is that we will have transitivity in these. So if we have two values that go to each other, so any kind of path that connects, we don't need to draw them. So notice how 1 goes to 4, which goes to 8. So we can go ahead and get rid of this path here. And so remember, the thing that we also assume is that it goes from bottom to top. So we're ordering smallest down here, largest up here, or at least for the divisibility. So down here means this will divide whatever we have up top in the path. All right, so let's see what else we have. Well, 1 divides 2, which divides 4. So we don't need this path from 1 to 2. Okay. We'll also notice 2 divides 4, which divides 8. So we don't need a path from 2 to 8. So 1 divides 2, which divides 6. So we don't need a path from 1 to 6. We have 1 divides 3, which divides 6, so that's okay. 1 divides 7, and 1 divides 5. So actually, let's make this look a little bit cleaner, because I don't know, that's not very pleasing to the eyes right now. So just so we don't have any kind of like cross wires or anything, I'm going to draw this in the following way. So I'll have 8 here, 6 here, 7 here, and 5 here. So for 8 we had 4, and then here we had 2. And then 6 has 2 and 3. And then for 1, it just goes to 1, it goes to 3, and then it goes to 7 and 5. So this would be a much prettier looking Hasse diagram for A. All right, now let's go ahead and do this. The same thing for B. All right. So 13 doesn't divide anything, so we can just go ahead and put that down. 11 doesn't divide anything, 7 doesn't divide, 5 doesn't divide, 3 doesn't divide, 2 doesn't divide, and 1 will divide everything. So we just put 1 down here and connect them like this. So actually that would be the Hasse diagram here, because we don't have any of the reflexive loops. We don't have anything with the transitive property we need to get rid of. And 1 divides all those, and it's below everything. So that would be our diagram for this one. All right, now what about C here? All right, so let's start with 48. So 48 doesn't divide anything. That we have in the set, 36 doesn't divide anything. 24 divides 48, so we can put this down here. 12 divides 24. It divides 36. Let me put 12 over here actually. And it divides 48. All right, now 6 will divide all of these. So 6 divides 12. It divides 24. It divides 48. And it divides 36. 3 will also divide everything. So we have 3 here. So 3 divides 12, it divides 36, it divides 24, and it divides 48. Then we have 2. Well, 2 divides all of these except for 3. So we're going to have, let me actually do this in a different color so it doesn't get too messy. So we have 2, well, this is going to divide 6, 12, 24, 36, and 48. And then 1 is just going to divide everything. So I won't really draw that one out. All right, so now let's see if we can erase some of these though, because that's going to be really nice. So over here, when we make it nice and pretty, we're just going to have 1 down here, and then we're also going to have 2 and 3, because you might notice that 2 and 3 divides everything. All right, so let me just connect these. So let's see. Well, notice that 6 divides all of these, and 3 and 2 both divide those. So actually, when we come over here for our diagram, we can just go ahead and do this and then get rid of all of the loops from 6 and 3. So actually, let's go ahead and just erase all of these really quick. So everything coming off of 6 and 3, or 2 and 3, we can erase. And we just need these to go into 6 here, like this. And then we have 1 there. And then we can erase the rest of this red line right there. And let's see what else we can erase. So notice that 6 divides 12 and 12 divides 36. So we can get rid of this line here, like that. And also 6 divides 12, which divides 24, so we can get rid of this line here. And well, 6 divides 12, which divides 24, which divides 48. So we can get rid of this line going to 48. And then 12 divides 48, but 12 divides 24, which divides 48. So then we can do this here. So that's going to be our graph. So let's go ahead and make it a little bit pretty over here. So this is going to be 6 to 12. And then over here, we'd have 36. Over here, we'd have 24. And then this goes to 48. So this is going to be the Hasse diagram. And then remember, it's directed going upward. So 1 divides 2, divides 3, 12, 24, 48. 2 divides 6, divides 12, 36. 12 divides 20, or 2 divides 24, divides 48, and so on like that. All right. So we have 1 more to make, and then we're done with this. So we'll do the same thing that we did before. So we'll start with 64. Okay, well, 64 doesn't divide anything. Well, 32 divides 64, so we can do this. And then, oh, this should be 16, not 6. And well, then 16 divides 32, but 16 also divides 64. All right. And then we have 8. So 8 divides 16, but 8 also divides 32, which divides 64. Then we have 4. So 4 divides 8. Let me do a different color for this one. So 4 divides 8. It divides 16. it divides 32, and then it also divides 64. All right, and then 2, well, this is going to divide 4, is going to divide 8, it's going to divide 16, it's going to divide 32, and it's going to divide 64. And we know 1's going to divide everything. So when we do that, we'll just put 1 at the very bottom here. All right, so notice, so 2 divides 4, but 4 divides 8, divides 16, divides 32, divides 64. So what that means is we can get rid of all of the paths out of 2 other than the one going to 4 due to that transitive property. So we can just get rid of all those blue lines. All right. So over here, when we draw this, so let's just kind of do this as we go. So it's 2, and then we have 4 like this. Now for 4, what do we have? Well, 4 divides 8, 8 divides 16, divides 32, divides 64. So that means for 4, we can get rid of all the paths other than the one going to 8. All right, so then that means we just go straight up to 8 here. And now 8 divides 16, which divides 32, divides 64. So then we have a path that hits all of those, so we can get rid of all the ones coming out of 8, other than the one going to 16. And then 16 divides 32, which divides 64, but 16 also divides 64, so we can get rid of that there. So just to make this all one color, this would be our directed graph here, or our Hasse diagram here. So it's just one big line going from 1, 2, 4, 8, 16, 32, and then 64.